Look, guys, I have this poster. I have ferrous alloys and non-ferrous alloys. Correct? You have ferrous alloys, those are the ferrous alloys allowed for marine environment. Non-ferrous alloys, all of those alloys are allowed. Alloys based on aluminum, alloys based on nickel copper, alloys based on silicon bronze, alloys based on beryllium copper, or alloys based in copper, in nickel and aluminum. Those alloys are allowed for marine environment, non-ferrous. You have that poster in your book. If you want this poster, you can buy this poster. Okay, this is for the alloys. This is the pedestal. And this is the boat. And this is the outlet of the boat where the shore power is connected. Everybody follow me? And here from you have a hot suppose that is double phase. You have other hot. You have the neutral. And also from here, from the side of the panel, you have the ground. And the ground enters here and goes directly into the ground bus bar of the AC panel, and after that into the what is this?
Bonding.
The bonding conductor. Where is located normally?
Middle of the boat?
On the stringer.
Oh, okay.
And the bonding conductor is connected outside with the sacrificial anode. I put zinc, but could be other metal. That's the ground. And here I have located what? The galvanic isolate. Okay. This is the protection. Okay. Now here this is the AC, the main breaker, and those are the small breakers. This is the AC panel. Yeah? AC panel. And look at this. This is the isolator transformer. Look at the function of the isolator transformer. I have hot, and after that continue the other phase, and this one in the middle is the neutral. Everybody follow me? Because neutral and ground are connected together with the frame, only at the source of the power. In the secondary, I have exactly the same situation. This is neutral. This is phase 2. And this is phase 1. That's okay? This is the ground produced for the transformer, and that ground will be connected here. Okay. Suppose that I have this ground contaminated, like we explained before. We have current in that ground. This element protects the boat for a ground contaminated?
No.
No. This one protects the boat?
Yes.
Yes. Because this one internally have diodes. Diodes located in different positions and capacitors and block that current. This one, suppose that that current enter contaminated here, and that current continue contaminated here. This is not a filter to clean ground. This is, what is the function of this?
Clean the sine wave.
Clean.
Look at this.
AC.
What happened with this signal at the input? It's like this, no? What happened in the mirror with the signal? Will be
Clean.
clean. Okay? This I'm going to use the voltmeter here, and we are going to check volts DC. Volts DC. And we are going to connect here suspended in the water the silver chloride electrode. This is the water line. I connect to the negative of my voltmeter. And the positive LED will be touching the ground or the metallic element that I want to see the difference. If the boat is fiberglass boat, the reading here should be in minus 0.7 to minus 0.9 volts DC, for a fiberglass boat. If the boat is aluminum boat, should be in between 0.5 and 0.7, and if the boat, in the book you have those values. All right, but this is not important. In this moment, I check the negative. I connect the silver chloride electrode suspended in the water, not touching the boat and not touching the ground. Suspended in the water. And I touch the metallic element that I want to see if it's properly bonded. Okay, the true hull, minus 0.75. Okay, it's good, it's properly bonded. That block, minus 0.3.
Oh, the probe has an extra wire on it? You can do that?
Yep.
Oh,
You need connect that element to the bonding system of your boat. Connect to the bonding, prepare the cable. Now the reading minus 0.79. That's a perfect demonstration. Good? Right? This is the silver chloride electrode. You need a silver chloride electrode in your tool? Yes. To demonstrate to the customer that is good. And also verify that in the panel you don't have reverse polarity. Reverse polarity is, but when you use the sure test, you know if you have reverse polarity. Be careful with this, pay attention. Some inspectors, they use the yellow block to check the outlet and verify if the outlet is properly wired or reverse polarity. And they say, oh, I found it in the galley of this boat, one outlet with reverse polarity. And other one in the master room. This boat is run. Excuse me. In the panel, in the AC panel, I have reverse polarity? No. It's in that outlet because some people wire and proper that outlet. And I have reverse polarity over there. That situation affect the boat? No.
That's how they get you to get more money.
Correct. The wire of your boat is run for that outlet? No, it's different if you demonstrate to me that the entire boat is reverse polarity. Because the power coming from the pedestal is switched. No? Oh, this is different situation. The entire boat is reverse polarity. How can you verify if the entire boat is reverse polarity? You go to the panel and you check voltage in between neutral and ground. How much should be the voltage in between neutral bus bar and ground?
1.0.
0. Oh, I have 120. You have reverse polarity because you have hot in the neutral, like your boat. Oh, yeah. Now you understand? In that particular case, the entire boat is reverse polarity. No one outlet. One outlet I solved it. I switch the cable and finito. Good, papas? You can go in the pedestal. Normally you have regular outlets, 120, in the bottom of the pedestal, all the pedestal. You can check the condition of the pedestal with the sure test. Can you come here and we check this pedestal? Look at this. If the three lines are solid, is correct. You see? Correct wiring. If only this and this are solid, is open ground. If this is blinking, blinking, and solid, reverse polarity. If this is not solid, not solid, not solid, open hot. Yeah, those are the possibilities. We have good wiring. Okay, let me check. The voltage is 122.7. It's great. It's a good voltage. Look at this. The voltage drop is 5.7%. You remember how much should be the voltage drop? In between 3% and 10%. You remember? You remember in the book? It's 5.7. It's good. It's a good voltage drop. It's in the range. Look, you remember in my book of corrosion, when you try to identify if you have leaks of current, how much in this moment nothing is connected to the outlet. It's supposed that the flow of amps should be zero or maximum 1 milliamp. 0.001, 1 milliamp. This is exactly in the limit. It's good. You see? That's perfect. And look at the resistance. You remember in my book how much should be the resistance? Can you bring the book quickly? Correct. Thank you. Look at the volts, and this is the ohms. How much should be the ohms maximum?
1.2.
And we have 0.23. That's perfect. No leaks of current. This building is perfect. And you see the intensity? Look, the intensity should be no more no more than 0.001. You see? That building is perfect. And the faces are okay. With this, you can diagnose the pedestal. Yes or not?
Yes.
What is the name of the tool?
Sure test.
Sure test.